Hi, I'm Emily Baldwin reporting for ESA Web TV, and I'm with the OSIRIS team, the high-resolution camera on board Rosetta, and Holger, principal investigator of the camera. How does it feel now that you've submitted all of the images into the archive?
Well, it's a true relief sharing all these wonderful images, including our high-resolution ellipses, the lander finding, and then the final descent of Rosetta. Now with all the world, so it's really a treasure chest to humanity, and we are very happy that we can share this now.
And with the final release, it covers the last 2 months, roughly, of the mission, so August, September 2016. And there are some very interesting images in this set. So you mentioned already the last images. Talk us through those very final moments and what you saw.
Well, the final moments are actually final hours. So the final hours of descent, so with the final mosaic, with the scan of the mud pit we were so much after, and then the slew over to the rest area of Rosetta, and then of course the descent going down very slowly, so not rapidly. It's not a crash landing. It's just let it sink down there and rest in peace. And we got all the wonderful images with the best resolution ever up to the very last moment, and so it's a wonderful feeling sharing it now with all of these people.
Thank you. And Carsten, for you, you were particularly interested in the final kind of orbits around the comet and those images. Talk us through that.
Yeah, just before the descent, when we already were a bit more risking the whole mission, the spacecraft, we're going really, really close. So we were on elliptical orbits, and twice a week we were getting really, really close. And every ellipse we were getting closer and closer and closer. And I think the closest, Holger, was like 1.7 kilometers to the surface. Yeah. And this is just, I mean, for the camera, we are all after resolution, and this is the best resolution we could ever get. And these are, for me, these are really my favorite images of the whole mission.
3 centimeters pixel
3
resolution.
centimeters per pixel, yeah.
On a comet 600 million kilometers away.
We had planned these images. We were standing in front of the screen when we were so much enjoying when these images came down. We were like, oh.
Me too. It was great to be there to share them with you. And I know there's another set of favourite images for Cecilia, because in this last release are also the images where we finally found Philae. Well, you found Philae. Talk us through.
Yeah, well, it was a while that we were trying to really get this image where we could really see Philae on the surface without any doubt that was really Philae. And we had planned a series of images, and then finally one day these images came. Well, we had some issues with the images because the pointing uncertainty, because the spacecraft was very close, and the footprint on the surface was very small. So we were imaging, and the lander was not there. We were just getting this position of the lander out of the field of view. And then one day, well, some images, it was a Sunday, and these images came down, and it was Sunday evening. I was at home, and I thought, well, okay, let's have a look. And I had kind of lost hope to find really Philae. And the day after was very busy, so I started looking at the images when I was at home, and one of my kids was there with me on the sofa. And when I saw that some boulders, which were supposed to be on the edge of the images, were actually right in the middle, and that I really lost hope, thinking that again we had lost Philae. But then there was a shadow area on the side, and I stretched the contrast to see what we were seeing in that area, and I saw a vertical line, which was strange. It was artificial. And then using the other images, well, that was Philae, and this was unbelievable. I mean, I could not imagine that we would have seen it so big, so clear, without any doubt that was Philae.
It was really exciting, and actually, even 2 years later, the story that we published on the ESA website is still the most viewed story of all time. I think 1.5 million views. It really captured people's attention to find it just before the end of the mission. But moving on, actually, it's not the end of the mission for the OSIRIS camera. The team are very busy looking into the data and finding new results. What kind of research are you looking into right now, in fact?
So right now I'm looking at all these circular features we have on the comet. So it's very striking that you have a lot of roundish features on the comet, and I was trying to look if there is a similar origin of them. So, for example, you have these deep pits that are cylindrical and 200 meters wide. And you have in the Imhotep region, that's like the bottom of the main lobe. And there you have also circular features that are elevated. And I was looking into impacts of rocky bodies or icy bodies you could create these pits, and these pits would then evolve into these circular features in input.
And Shan, you recently just had a paper published about the activity of the comet and the relationship with the strange shape of the comet. Tell us, what did you discover?
So we used these wonderful high-resolution images from OSIRIS and try to link the jet features in the near-nucleus coma to the surface. And through that exercise, we can actually distinguish those factors that help to produce these jet features that we see in the coma. That's something could not be done with data before Rosetta, basically. It's a merit of the data set.
So moving from looking at images and then applying models to help understand what we're looking at. Johannes, how are you doing that?
Well, basically it's a lot of mathematics and computer software development, and we have physics, and then we try to build computer model, and then we can calculate some predictions what we can actually see. And
in order to understand the images, we also need to look at them in different filters. So tell us where we're at with that aspect.
Yeah, we have the OSIRIS images in a different color filter, and this help us to produce RGB image, which then you have these gray images in the color image that's it's more sensible to the human eyes. And then eventually with this RGB image, it's also possible to map the surface in 2D and mosaic all the images that we produce from the OSIRIS high-resolution images.
Well, there's certainly still a lot going on with the OSIRIS team, and with all the images now in the archive, there's plenty more science to come as well. Enjoy exploring the images. I'm Emily Baldwin, reporting for ESA Web TV.